So now we have the contract that's compiled. Excellent. So now I'm going to need you to help me design the next iteration. So we have an idea, we want to propose an idea for the next iteration. Don't be shy, guys. Just randomly say. This is a pre-discussion space. And next time, I'm doing one more test case, and then you guys are going to go on stage and do the next test case. Misha.
What? Do you want a test case?
What feature can we add? What's the next baby step we can do?
Create a transfer function.
A transfer function. What do you mean?
Well, it's a MultiSig. You need to be able to send something.
So you mean doing ether transfer?
Yes.
Right?
Ether transfer. Yes.
Who's going to do that? Anyone?
Yes. Anyway.
Okay. We like this idea. Okay, so let's do it. Misha, come. So you have the familiar with the studio?
Yeah.
Okay. This is a US keyboard.
Okay. No. So we want a function that will be called transfer.
So you're free to comment whatever you want. He has the keyboard, so he's the driver. So he can listen to us or not. He's free to do whatever
we
he
need,
wants.
I guess, a couple parameters. So what would be a good parameter?
Destination and value.
Okay. Destination and
We start with a test.
Oh, we should start by the test. Correct.
correct.
So you delete your code, delete your line.
No.
Delete your line because that's set to penalize you.
Wasted what?
Where is the
So
home and
okay, you're opposing this guy. I like it. So now
no,
this-
where is the test? Ah,
Yes, perfect.
okay, so yes.
So the way you read it MultiSig should exist. MultiSig can transfer ether. So we need to help you. So for your function,
Where is the bigger?
it's bigger.
Great.
So if you're not familiar with the code, you can express your idea for business concept. It still applies very well.
You're writing async because it only goes one way, right? You're sending ether.
No.
no,
The async is a JavaScript because we're writing JavaScript tests, and the async allows me to use the this one, the wait,
The wait.
which is a nicer syntax. It's just syntactic.
Okay.
But you need that because all you do on blockchain is asynchronous. When you have a normal database, you can be, well, it's not ideal, but you can do synchronous operation.
Mm-hmm.
You write, you wait, it's written, and then you do next things there. On the blockchain, you can't do that because you don't know when it will be written. So you all have to do is asynchronous code. It's the same for when you do JavaScript on the web page and communicate to web server. It's also asynchronous code.
No, it's about the driver, in fact. In the database, it's exactly the same. If the drivers operate on asynchronous I/O or synchronous I/O. Or basically the same as you would read
So
from the file.
what do you want to do as a test, Misha?
Okay, so my test will be I want to send away some ether. In order to send away some ether, I need to get some ether first. That's kind of the rule. If you want to send something, you have to have it. So the first step is to send some ether to my smart contract.
So maybe there is a smaller step then,
What?
which is not transferring ether, which is receiving ether. This is very correct what you mentioned.
So we need a block.
To be able to
before
transfer, you need to receive, so your contract needs to be able to receive ether.
Yeah, but okay. You know what?
It's very important to keep things when you do TDD as small as possible. The very tiny way perfect you can keep the transfer test. What was Misha doing? He was great because he was testing the transfer data, which is what mattered. But with only that test case, you don't know what's failing. It's failed because he can't receive, or it's failed because he can't send. So now you will know if he can't receive, both test cases will fail. If the transfer failing, not the receiving, then the receiving will pass, but the transfer test will fail. It doesn't increase the code coverage in this case.
Okay. So, for those not familiar with the Ethereum transaction, for those not familiar with the US keyboard.
Yeah.
Yes. Okay, so from
The US keyboard is very nice for coding because you have all the coding syntax easily available. Whereas in European keyboard, you have to figure the curly brackets and everything which are not directly accessible. You disagree?
that's an open discussion.
Don't say that the German keyboard is nice.
Never used a German keyboard.
So two, what is two? The contract.
Two, yes, the MultiSig address, and how much do we want to send?
100. 100, whatever.
100?
100, it's cool.
Did you configure your test RPC
Yes,
to get
it's
100
less
ether?
than- No, make it simple, one.
1 ether.
Because if it works with one, it will work with one.
Okay.
You didn't add any value from the in accounts between brackets from the front. Is that because you want to keep that as a variable, or because you don't have an address right now for the account?
No, so the accounts you see here has been passed here as a parameter.
Okay.
These are all the accounts that are known to my Ethereum node that I'm connected to. And the Ethereum node I'm connected to, I'm just guessing because I haven't followed it, but it's a test RPC node that is run locally and that has 10 addresses.
It's a Ganesh.
Ganesh. It's a Ganesh node that has 10 addresses. And so I know that all the accounts are unlocked and I can just use any of them. I could use between 0 and 9 here. Just 6.
Okay.
Where's just as well?
All the 10 accounts initially that you have with the test environment node have 10 ether, I think.
Yes, 10 ether. But
So it's better to use, well, you can have more, but you have to manually configure your test environments to say which account have how much. But then by default, since we don't have needs to change the configuration, let's just start with a less than 10 ether, which is 1 power of 18 way, which is the basic units that you use in the channel.
okay, and
Now
Cyril
you're
will
testing that
explain
you-
what I'm
just-
writing.
So now Misha has written asset.ok takes.status. Even that takes.status return true. So it's mean that the transaction was correctly executed. So that's why you need the weights. Because without the weights, you will say it failed. Because takes.status is not true. He has not had time to execute. But because of the weights, he will wait until it's executed, and then the takes.status will be able to validate if it has failed, because you don't have any more ether or whatever, or if it has been successful. Then, Misha is challenging and checking the balance of the account. Maybe Misha, you can try to keep the line within the display rhythm, if it's possible for you.
Yes, that is possible.
Perfect. So now we see that Misha is challenging the MultiSig address. So the destination of the challenging that contains one ether. which is 1 power 8.
Okay, let's try this.
Yeah?
I have just a question about the value we are sending. We are sending 1 ether.
Yes.
I've never found like a quick an answer for this. So when you are like sending 1 ether, you have to pay some gas.
Yes.
Okay. So then you are just testing if the balance of the contract is equal to 1 ether. Will have 1 ether at the contract balance, or it will be 1 ether minus the gas? Who
No.
pay for the gas?
The gas is from the sender.
Okay, so it's not the, so if like in the value I'm sending 1 ether, it will be 1 ether, and then I will have to pay the gas for this,
Yes.
right? Okay.
Correct. So the sender will have his account debited by more than 1 ether.
Okay.
1 ether plus 21,000 times gas price.
Okay.
By the way, we could add a test cases that check how many gas we spent.
Okay.
We might not want to be too concise because we will have to modify every time we change something, but we can say that in our requirements, we don't want a transfer or receiving operation to cost more than 200,000 gas.
Okay.
So that's something we could do to challenge. So that's also the power of TDD, is that you can learn a lot
Control the gas.
because you can try test cases and challenge your assumptions, and you can put your assumption within the test case, and you will know they failed. And maybe not now, but you will know later on. So it's good because you can project on the test your assumption you have in mind and challenge them over time. And maybe you will learn that's wrong and you will adapt. Great?
Yeah, where's the...
So yeah, now we're going to, with this test, trying to send ether to this contract, but we don't modify the contract. If I'm correct, as long as there is no fallback payable function, it will fail. And
Yes, that's what we want to do.
But it's on purpose that we fail.
It's
and
on
then we
purpose.
don't correct
And
it.
why it's on purpose? Because we failed for the right reason. We failed at the first test case is still running, so we didn't break anything. We didn't discover new stuff, and also that we failed for the right reason. So now, as you mentioned, the implementation is to write a payable function, which is what is called on the smart contract when the smart contract receives data. So far, 100% of the code is covered. We don't have one line which is not covered by the test case, which is not a big challenge because we just have 3 lines. Aha! The array is not ready. Okay, we'll check that later. No one can read the array, right?
Expected.
So maybe let's read it. So here it's a 1 failing, and it's an assertion error expected undefined to truth. And it's okay. Line 26.
Yeah, okay, I was just expecting
So
something.
line 26 should be here. So this is failing.
I was expecting... no, I know why. But, that's an
So the
assumption error. It's that the transaction that is returned by the send transaction
receipt.
after the await is
Not-
the transaction
is a
receipt.
receipt.
Exactly. And so it has no status.
So
If
do you
want to have
differentiate
status-
what the receipt of the transaction and the transaction itself is? So the receipt just say, oh, with the network, with the nodes, I've received your transaction. It's now pending. At some point, so you can have how many transactions pending in the network as you want. They will only stay there for 250 seconds or so, I think, or for a short period of a sufficient amount of time, but not too long. And at any point in time during that period, the miner of the block can add the transaction to the block he's building. So the receipt just say, okay, we know you have made a transaction. We confirm you that you have a transaction pending, but it's not like the transaction itself, which is only define what the block exists.
Okay. That should work. Let's try. hack.
So you follow what Misha is doing. You please ask questions if anything is confusing.
Okay. This
So what was the error?
It's null.
Okay.
Property toString of null.
So the error is part of the.
I guess that the property transaction hash does not exist.
And maybe you can console log the take subject if you want to be more.
So this is the real downside of truffle testing. You cannot set breakpoint. So we're back to the 80s with debug.
The famous hello, I'm here in the log. Hello, I'm here. Have you ever seen that? The developer write, hello, I'm here.
When you don't have
Sometimes it's worse. Sometimes you see nasty stuff. You see like, who's the fuck writing test cases at this point? If you ever see that line, it means you discover something I never figure out.
Then you have
It's kind of like-
1, 2, 3.
1, 2, 3. Good one. So what was the log?
So it's the transaction is the transaction hash. So this is the transaction.
Yeah. Oh, it's the hash, not even the receipt.
Exactly.
Okay.
Now it's
Yeah, you see the hash on the top.
see? Nope.
So expecting and defining to be trophy. So same thing.
So I'm guessing that
You want to cancel out the transaction?
no, I'm gonna skip this and go directly to testing the balance because we know that it succeeded.
So imagine he's a powerful senior blockchain developer. Imagine. But it's good because it makes you relate. I'm not better than him. I was just about to define an empty contract.
We assert that the balance is 1 ether. So success.
Yay!
Yay!
So now I'm suggesting that someone has come and write the transfer function.
No, first the test.
Of course, not the test. Someone wants to volunteer. Come on, guys, don't be shy. All the code is already written. You just have to copy paste what already exists. It's quite trivial. No one's. Come on, don't be shy. Come. You. I'm gonna name people. Be ready. Not the camera. So it's a US cable. So what you have to do is write a test cases that can send it. So the first thing you need to have is to have some Ether in your account.
Okay.
So what you can do is define some kind of new space of test cases that will have a different initial or will have added initial conditions. So right now the initial condition of all the tests are a deploy contract.
Okay.
What you want is a deploy contract which also has some eternity. Because you have more than one test.
When you say initial ether init is in the smart contract?
Yes, in the smart contract.
In the smart contract? Okay. Okay.
So the way you do that, you encapsulate it into a describe function. So the same, you see the it text
Okay.
async function. You just encapsulate it instead of the it, you say describe. And you say describe with
Never saw this.
with a wallet charge, with Ether in the wallet. Async, the same. You just encapsulate the it.
Let's do it together.
and describe. So the line above, you start the line above. Yeah. Describe. Open the parentheses. So this is closer to BDD. Most of the, because in BDD you use always the term describe. So now you say a message with Ether in the wallet, with Ether, just with Ether, with Ether in, because imagine still that within the, it's done with MultiSig contract
Okay.
with Ether in it, can transfer Ether. MultiSig contract. MultiSig is here, the text should exist. So you have a sentence, you define a sentence. MultiSig, so with Ether in it, in the describe, can transfer Ether.
So it's just a message.
It's just a message, but you split the message because you're going to reuse the part of the message on several tests. Okay. So maybe if you want, don't do the describe.
Yeah.
We'll do like I will do it just after.
Okay. So
no, stay here. Stay here. Okay. We just don't do the. We'll do the describe. You will understand the describe later. So just do now. You just manually send Ether to the smart contract. So basically, you just copy paste what's just above.
Okay, so I will send some Ether from account 0 to the smart contract.
Perfect. Account 6 or 0.
Okay, and do we have to like save the transaction or the receipt or no?
Do you think we have? What do we want to test?
We want to test if we can transfer.
So we don't care about the.
Yeah.
We just want it to be ready.
Okay.
But we still want that the transfer has not failed. So we want to ensure that initial condition, because they can fail, we want to ensure that initial condition have been successful. If we don't do that, then it means the test will not run in proper condition. We don't have the initial setup, and then the test doesn't apply exactly as we want. But you should just copy paste.
Okay.
You selection everything except the assertive code. No, with the assertive code, sorry. You just select everything.
With the set.
So all the text
All this one?
from line 20,
Okay.
from line 20 to line 29. You just copy paste it. You will understand why I was meaning the describe later.
Okay.
So this is not ideal because we're duplicating the code, but you will see why we get that. So you have the C before. Okay, so now you have your initial condition defined. So now what you can do is try to transfer it. So the next line, of code 42, you can write your transfer function. So do you know how to write it, or do you want me to guide you?
To transfer from where to where?
From the wallets to whatever account you want.
It's like send transaction from account 0
Pretty
to...
much, except that send transaction is Ethereum, Web3 Ethereum operation.
Okay.
And here you're going to do a smart contract operation.
Okay, so I'll let you do it.
No, you go for it. You're good so far. It's like your initial.
Why did we repeat the transfer?
We should have used. We're going to use the describe. So far, right now, in TDD approach, very basic and trivial mindset. That's a refactor step that we're going to do at the end of the loop. Right now, we just write the simplest code. That's go through it.
But then, no, you cannot do that in truffle.
What do you mean?
Because you have to account for the tests that have occurred before.
They're isolated, I think.
No, they're not. So this test will fail. Right, as it is now, it will fail.
Why?
Try it.
Okay, try it.
Save it first.
And experiments first, because you have 10 Ether. You can send twice.
The balance is wrong.
The balance is wrong. You check that. No, it's passing. I think the tests are isolated.
No, they're not.
I think they are. Because you have the before each. What you have to account is the before each, which is very important.
And in the before each, you do.
You build the setup. And that's why we need to describe, because we're going to do a
Okay, so
before
I
each.
missed a before each.
But one step at a time. So now, after the asset call, you do the transfer operations. But you can't do, sorry.
I just have to understand what you are doing because I'm
So what we're doing is okay. Transfer Ether.
Exactly. This is what I wanted to understand.
But first, we need to do the receiving part.
Okay, so now we are just sending Ether from account 6 to the contract address.
Which is the requirements for the test. now we start doing the test.
Okay.
So now we need to do an operation on the smart contract.
To translate from the smart contract to
Yes.
another one.
So
Okay.
now you have to define, now you have to be creative.
Okay.
And what function do you want to add on the smart contract? That will send,
It's a variable function.
no, variable is
To send.
to send.
So
So basically the web operation is web me, ETH, send transaction.
Okay.
You're going to do that. The problem is that you're not going to do that as you, you're going to do that as the smart contract.
I have to be the owner for the smart contract.
No, we don't speak of the owner right now.
The thing is that
All we need to do is add on the smart contract. Okay, so we have
This is the MultiSig.
okay, so we did something not ready. Okay, let's do like that.
that's a very basic test.
Okay, so we need to have another function that will allow us to induce an operation on the smart contract, which is transfer money.
Okay.
So imagine you write, don't write it now, imagine you write what function do you want to have?
It's just a function that will have as a parameter the account where we have to
Exactly.
send. Okay.
So you can do with one operation if you want,
Okay.
and send always to the same destination, or you can do one with a destination, always a fixed amount. You're free to do what you want.
Because then
So whatever you want. So start with the test case.
So you're familiar with this test?
Okay, so we'll imagine that we will have a function in the smart contract that has
That you will
parameters.
execute on the second time.
and then it will execute only this test.
And that will be so
So your contract is MultiSig.
yeah. So
MultiSig does,
Okay, so it's
that the function name
and then you call it how you want.
transfer.
If you have idea, we can add your idea as well. Don't be shy. Raise your voice. So now we create a function which allows us to transfer. What do we want to transfer?
First parameter will be the destination. We can be the amount.
So I would suggest, and that's my point, to use the same convention as Pelerin doing on the API level.
So it's from to value.
We may not want to do from because we know the from,
Is the smart contract.
but we can do the to and the value.
So the 2 and 0, the crochet.
S plus S. S. 0. Perfect. And what the value? 1 exponent 18?
Yeah, to 1 ether, okay.
We could have a different API. We could just say that we always send to ether. No matter who calling, you send to ether. Or maybe depending who calling, we send to ether.
And now you will have some problems with the fee. Yes. If you are transferring, how will you pay the fee?
Ah, that's correct.
We will.
No, it's okay.
Just go ahead. Go ahead.
Gas.
It's actually okay. It will work.
Yes, because the sender is the caller.
It's because the sender is not the smart contract.
Exactly.
Because the sender is a
Sender is not a smart contract. Okay,
But it's, you have to try and fail. So what is it?
Is the invoker of the function.
Okay.
Okay, so now what you have to do is, how do you want to, so now you do the operation, perfect. How do you want to test the operation? So what are the end results?
I'll have to.
In the end, what happens when you do the transfer to account 0?
So just test the balance of account 0 and see if they have the balance.
Perfectly good.
Okay.
And I will not look only the account 0.
Okay.
I will also look that the account MultiSig is different.
Yes.
Because imagine you created value.
Okay. So now we just test the balance of the
Just take the
MultiSig
balance,
contract.
so you have these 2 lines you can duplicate.
Okay.
And you're good to go. You duplicate twice, one for account 0, one for the contract, and you should be good to go. Okay, so now we have MultiSig and the balance number is 0. Everything is fine with that? You're already shy. I can hear Elodie speaking.
You cannot test the balance of a country.
You are the only one to speak in the room. Don't be shy. You're the only one speaking. We want people to participate.
Yes, sorry.
I feel
Don't be
lonely.
sorry. Then just speak. Then talk. I'm pretty. I can put the lines. I want more lines for you guys. I can put those lines towards you.
For the second test, I think it will not work. For the account, the balance of accounts.
Copy paste, and we're going to try it. So make your assumption here, what you believe should be, and then we will challenge the assumptions.
Okay, so I can
You duplicate. For now, you don't be efficient. You duplicate stuff. We'll refactor later. Icon 0.
It won't work. Okay.
Make your assumptions. The interesting part is that you challenge every time your assumption, so you know if it's right or not. Okay. You can right click and do it on OK. You can have the automatic refactor, automatic formatting. Okay, we're very good.
Is it okay to have a constant?
Oh yes, you can't. You have 3 times the same constant. So either you change, you don't do constant, or you put different name that balance.
Balance 1, balance 2.
Okay.
Balance before, balance after, balance account, balance contract,
Okay, that's it.
You have 3 times.
and then you have to change it in the assets. So with the bit which is not very familiar with the assets and the testing frameworks, okay. Or others are very familiar with testing frameworks. Yeah, cool.
Okay, let's test
But
this.
next time we'll do TDD with DAPHub.
With
DAPHub.
if you want. You come here and you want to do that. You want my host, you're my guest. Whatever, you both. Aha, wait a second. Alors, so you have to read it because it's really not really low.
Yeah.
MultiSig transfer is not a function.
Because I didn't write the transfer function.
Well, which, very good. That's what we wanted. So now you can write the test case, the code. But now you write all this. Does your understanding and your vision of the code is very, very clear, much clearer if you had started by the code.
Yeah, because I know exactly what is missing and why it doesn't work and
Exactly.
which code I
You do
have
all
to
the analysis. So this is the business requirement, the functional analysis. And now you're going to write the technical parts. Okay. Which is very funny because now you know that you have your armies. You put a Q instead of a- I'm trying to figure out who will be next. So I tend to like to be explicit about the, it's not about this, no worries. But I tend to like to be explicit about the size of the units.
Okay.
I rather to 256
Okay.
rather than units.
If I were just you,
It's perfectly correct.
Is
It's just your own convention, your own way to do it.
Okay.
I don't know what you guys think. That was to discuss. Do you explicit the type or do you keep units?
I always explicit the type. And the reason is that when you look for the hash value of the function, it will use the U1 256.
Explicitly.
Explicitly, yes. And it is very frustrating to trying to create a hash from the source. It doesn't work because you forgot.
Thanks a lot. So now what's happening? So in this case, you have to call the Ethereum transfer function, which is, I think, just
It's send.
send transaction.
Because there's send and there's
This
transfer.
dot send.
Send.
I know this changed in the late. Try this dot send and we will get a
Well,
compiler error.
just try.
Send.
And we'll look on Google if we need information. That's really a shame. We're a dev meetup and we don't know the same camera. No one's know.
And do you know the difference between send and transfer?
Yeah, it's about the required statement. It's like you have a fallback if it fails.
No, the
On transfer, but
the
not for
send
send.
triggers the fallback. The transfer does not.
Oh, you mean the call?
If here instead of send he wrote transfer, then if the destination is a smart contract, the fallback function which we wrote above would not be triggered.
Aha.
In my mind, it was the opposite. It was the
I would have
opposite.
said the opposite as well.
It's the
I'm pretty
transfers
sure,
it
but-
transfers the new one.
Okay, go ahead. No worries. We have the whole crew there to answer your questions. Okay.
So if you are using the wrong command, you can lock ethers.
Yes.
Having the way to get them back. It's very good to know before.
That's why you do test cases. You will never write smart contract the same way.
This, I think, is this address.
You can. I'm not sure you have to write the from. But
Yeah,
it's not a problem.
Okay.
No, you don't do this address. You do address parentheses this,
Okay.
because this is already the address. You just have to type it to cast it into the address. So you just do address, and in parentheses you put this.
Okay.
Then the 2, which is the parameter. And the value will be Q. You're familiar with the
Yeah, I work on a French keyboard. And the value, so I have to transfer it to way because we are sending one.
No, we send
No, we are
it
sending way. Okay.
with the same units.
Okay. So amount.
Good.
Okay. So this is much.
Are you have the parentheses problem? No. Why does it say there is no? Look at the put your mouse on the code, the curly bracket line 12. What is it? Expect it. So you're missing a parenthesis. Look at the end of the line. So try to split it in two.
So both. So it has nothing to do with the
No.
What is
But you can do nothing.
put the semicolon?
So you get just enough cast.
No.
So it must be in the function.
What do you use? Click, put your mouse on the send function. And the client, these dots, try these dots. Because you don't have this, no. So it's not send. So, because you guys don't look, I have to look myself as well. So send, solidity.
No, so what I found is that the difference is that transfer throws on error and the send returns false.
Okay. Then there is a type of syntax error here.
Why we have this?
No, that's.
It's not
You
visible.
just give an address and an amount. You say send address, comma,
Oh, it's not an
amount.
object.
It's not an object.
Okay, that's explicit.
Okay.
And it is this dot send. That was correct. That was
Okay.
correct.
So the first parameter is the destination. Is the
But
two.
without the curly braces.
Okay.
Just address this, yes. Oh, and I think what has changed is you have to say address this send.
So let me have a quick look to understand
This
that.
transfer is address.transfer.
So there is,
Or the
I do have
function
this
does not
Zeppelin.
exist. It has to be called on address. It's like address.send.
I do have the open Zeppelin thingy, and I'm pretty sure in the crowd send contracts there is some send operation.
You have transfer.
So this is the transfer they use.
You have to call it on an
C'est
address.
là. En fait,
You call it on the address.
tu dis où tu vas envoyer et tu dis combien.
Exactement. Donc c'est le tout point transfert.
Exactement.
Ok, we're good to go.
C'est pas des en fait, c'est voilà, c'est tout transfert et donc. Tout ça.
Tu dirais?
L'accolade à la fin. L'accolade.
Ouais.
Ah ouais, le clavier. Et pourquoi il y a
To the transfer?
Yes.
C'est là où tu veux envoyer.
Ouais, ouais, the transfer, c'est the same. Pourquoi le to il est en...
C'est pas la déclaration.
T'as oublié, t'as fait transfer. Yes.
Ah.
Right. So what the output of the part, is it a boolean? Or it's a,
No.
it's a-
That's the one that throws.
Perfect. So we're pretty good. Do you want to do the test cases now? So ideally, in a rare situation, you will want to test the exception case. You want to test when you don't have a balance.
Oh.
Expect 100 to be 0.
So it means that you return a larger amount than zero.
No,
Line
it means that the transfer didn't go through.
I believe so. Which line is it?
for this one. This line.
Okay. So the weights, you forgot
No,
the
c'est
weights.
normal.
Yeah. Okay.
You have to put in before transfer, you have to put the weights.
No, it's not that. It's that the balance one is the MultiSig balance and not the destination balance. You just transferred all the ether from the MultiSig to account 0,
So it should be
and you expect it to be
zero.
to be
Zero. It's a weight.
Sorry.
You have to put the weight before the multisig, otherwise you're testing before doing the operation.
Yes, correct.
So line 44, you put the weight before.
Can you transfer the full amount without leaving anything to gas?
Sorry?
Yes, because the caller
Oh, yeah.
pays the gas, not
So-
the
Yes,
contract.
perfect.
The contract never pays
try
gas.
it.
That's a big flaw on Ethereum. It would be so nice to have the contract paying for gas.
It would be too nice to have the contract be autonomous and be able to schedule its own call.
But no, schedule its own call.
That would be too nice. Because every time you have to, humans to parents.
But
What is it? So comment there so we can do more. Aha! Look what we have. Look what we have. Very interesting. So what do we have?
It's the balance of the account 0.
So by default, the account 0 has 10.
Yeah, exactly.
So you send from another account because you have 10 itself plus
It's the account 0.
something less than 1. So go back on the test. So this one, but you took from the 6. So it means you have 10 plus what you send from to it.
This is not that we just have to capture the balance just before the transfer and then see if it's equal to the current balance plus the transfer amount. You see what I mean?
Yes, exactly. It should be plus 1.
Yeah, exactly.
It should be plus 1. But what you have, if you look on the results, what you have 10 plus 0.9.
Yeah.
Because something has to be taken from the gas.
Yeah.
Misha, I think the gas was paid from the 1 Ether.
no, it's just the account 0 is the default account. So all the transaction you do without specifying who sent them, like creating the
Right.
contract comes from account 0. And choose account 7,
Completely right.
and then you will have 11 ether on it.
So what do you say we should add?
You should, on line 44, you should transfer to account 7, or 5, or whatever.
Aha, and it tells that account 7. Make perfect sense.
And
So
then
that
account 7 will have 11.
Because it doesn't pay for the gas, so it should be perfectly right.
Exactly.
Yeah, it's account 0 basically.
I will learn a lot. Okay. You want to do the next? You're very shy.
The guy who is speaking, you know, or the girl? This one.
That should work.
Yes? No? I think so. Well, you don't necessarily have to ask me. Try. You just say what you're doing, and you try. And
As long as it's not too big for JavaScript, it works.
Okay. I've already written
After you have
function
to
this is the first time I see this.
But you can use otherwise by default not it's open. Let's truffle. We come with big.js. It's Web3. We come with big.js.
And no.
What is the expect? It's 0.1.
So it has 100 ether.
It's 100. So it's 100. Sorry. How does it mean the other test worked?
No, it's a 0 in the middle.
Yeah, because in the
No,
other
you tell the balance.
Yeah, okay.
No, we tell the balance is correct. So it was 0, so...
Can you say it?
Yeah. The thing is, now the balance of the account 7, I have already.
No, it is
101.
reset.
It's
It is
reset.
reset.
Okay.
There's one thing more. It's refactoring. Okay. So now that this case works, you have the refactoring. So if you look at the code, you have duplication. You have duplication on the setup, and you have duplication on the balance evaluation. So I would suggest that you make a function which contains the check balance. Okay, so you make a function, for example, equal balance, which is the balance and the address. And I do the call and the equal.
And the function should be in the.
No, in the test. In the test. So it's a test function. That's how you to test the balance.
Okay.
So
I have to do it outside the iteration.
you do it wherever you want, but best is to do on the root level, so on the contract level. So just below the MultiSig, and then you write your assets balance function.
Okay. So this is just function
Assets balance. So the idea of refactoring, it's that now we have the test case and the code working, we can safely change the test. You should never change at the same time the test and the contract. Every time you want to switch from one to the other, if you want to refactor the contract, and you just modify the test, you have to run the test in between. So you ensure your RNS is already always consistent one versus the other. So you put asset, you put assets. Yeah, I just copy paste. So it's not a return, it's just the line 30 to 33, for example. 30 to 33.
This one. Okay.
233. And then you put parameters, so it gets much lighter. Instead of the return. You don't need the return.
So I just pass the code
paste.
Okay.
Yeah, perfect. And then you put parameters. So you have accounts.
Okay.
So account is good because you can check the address.
The balance of the account.
Yes. Replace MultiSig. Yeah, replace MultiSig by accounts. No. And whatever. Okay. Do you want to pass an address or do you have to pass an account?
I was going to pass an address, but it can be the
No,
account.
you can go for the address. Perfect.
Okay. So I will
It's
just
more
an
generic, I
account.
think. Yeah. And then you need the balance, expected balance.
The second.
Yeah, second parameter is the expected balance. So basically what you define, you extend assets with higher level function, which will allow you to make a more readable code. Expected balance. Perfect. And now you can do asset balance every time you do the thing. So date there, 33 to 66. So add first, delete them, because at least you know what you're writing. So you need to see the address. One exponents, and you can remove everything else. I think you have added the breakpoints where you analyze it. Perfect, okay. So you can do it below. So copy paste the line or just the function. Because you know that's what you have also here. So you can delete 43 to 46. Because it's exactly the same. Be careful. Yeah, balance. No, it's okay. Go for it. Okay. And now below you have twice the same function twice. And now it's 0. You can do 3 lines. And do the same again for the balance too.
You have duplicate like control V.
And it's account 7. The address is account 7. And 1 exponents 80. So the refactoring is very important because it makes your code more readable, more maintainable, and you know that you don't break anything. It's really good to maintain what's called the technical debt. Are you familiar with the technical debt concept? Who is not familiar with the technical debt concept? So basically, it's the idea that when you do codes, you iterate, you change things, people change. You introduce some kind of entropy, some complexity, which is not needed for the software. So you add more convoluted things and so on. So that's what's called technical debt. The measure in technical debt is measured in human day, in the time you have to, number of days the human has to pay to refactor or do all the stuff in the leanest way. So you never want to be at 0 because that's too costly to maintain everything. But you want to keep the technical debt very low, because if you don't pay the interest, well, if you don't pay regularly the technical debt, then at some time it will get so huge that you'll go bankrupt. Your software will break apart from many directions at the same time. So if you want to be large, if you do only small piece of code, it's not so much important because you can throw it away and restart it. But once you build something that's quite large, you need to have this technical debt maintained very, very low. And refactoring is the way to do that.
Okay, now we have another problem.
So the test is not running.
No, the web tree, it doesn't recognize web tree on the...
So you probably have syntax error. So white line is 12.
Where did you see the...
Sorry?
In the test, where did you see where the error was? I didn't have time to see.
So here,
Yeah.
MultiSig,
Okay, right.
line 12.
Okay, cool.
Can you go back to the test? I'm suspecting this is not an async function. It is not an async function. Or is it? No, it is not.
No, I think it is.
No, it is not. There is no async at the beginning.
Yes,
the
the
function.
function. The axial balance has to be the same. Very good. So when you use the weights, your functional way has to use the C.
But you also have to know JavaScript.
Yeah, because the error is not explicit. Travel is the word. Ethereum is the word, but JavaScript is not good. Perfect. I will just go one step further because I told you that there is a describe. Most of the test cases we're going to do,
You can also run
it's with a wallet containing Ether. Basically, you have two cases. The test with no Ether in the wallet, but not very interesting because they are limited. In a multi-sig that has nothing, you cannot do very much. You can still configure and do small things, but you're going to have a lot of test cases that will contain Ether, and you want to challenge that the Ether still works and everything. So what I'm suggesting is that we use the describe function. We use the describe function with ATH in, and then we do I think we don't need to use here function, and here we close it. I think it's just there. Let's do some formatting. And what's the describe allows, it allows us to scope the test cases we can do with it. And it allows us to do a before each. So it's a second before each, which is called after the first one. So this before each is going to be just an async function, I think. Yes, just an async function. And what it's going to do, it just puts Ether into the smart contracts. So now, every time we are reusing this operation, we're using this before each. And the way it writes, so you see that it's like contract MultiSig should exist, can receive ETH, and can transfer ETH. And now what we have is contract MultiSig should exist, can receive ETH, and with Ethereum, can transfer Ethereum. Okay. So what's the next?
Nice.
What's the next? I need a volunteer. Or you can eat hard on Robert, so Robert come. Robert doesn't believe in test cases. Even if test cases should be done in Solidity. I'm trolling. Just to be clear, I'm trolling. That's not what Robert said.
So, do you want some refactoring? Or?
So, I think we're good for the run. Do you think we should do more refactoring? What would you do?
We can check that here, just to have constant to see the lines.
Makes sense. Because that's your universal units. It's not explicit, it doesn't. When we read that code, we don't know why we put this value, specific value. It's not meaningful. So putting a constant can help us understand the test case. So the test cases, in the end, is the documentation of the code. It says exactly precisely how the code should be read and should be manipulated. Which is very smart because it's always up-to-date documentation tested by the code.
Just want to make sure that's the constant, right? CONST.
Yes.
Yeah,
Okay.
it just say constant. It's a JavaScript keyword.
All right.
Copy the equal sign.
Where do you put the constant?
It's on the top right. Top right of the key.
Yes.
Why do you put the constant here and not just even outside the contract?